Okay, day two is applications of the stuff we learned yesterday, the sine, cosine, and tangent, the right triangle trig. And we're going to apply it to some real-world problems. So my learning target, I can use angles of elevation and depression to solve problems. So what is angle of elevation and depression? What's the difference? So I started the definition here. The angle of elevation is the angle between the horizontal plane and the oblique line. Oblique just means at an angle. So say oblique, it's not parallel or perpendicular to it. From the observer's eye. So we say observer, it's not necessarily a person, the observer's eye. It can be a person, sometimes it's just an object. But the key here is for elevation, it's the person or the thing is looking up, okay? Up to an object. Where angle of depression, it's all the same stuff, but replace this word with down. Okay, so replace it with down. Everything else is the same. The angle between the horizontal plane and the oblique line from the observer's eye down to an object. So if it's looking down, it's depression. If it's looking up, it's elevation. So just to get some ideas here, angle one, the angle one, this was not a person, so we said observer up here. This is a mountaintop. Okay, so here's the horizontal plane. Here's the oblique line looking down towards a person. Towards a person. So angle one would be an angle of depression from the mountaintop to a person, to the person. Okay. Angle two, if you look at angle two here, here's that horizontal line, and this is going up. So angle two is an angle of elevation from person to mountaintop. Now, if you remember from geometry, these are both horizontal lines, so they're parallel, and this would be considered a transversal. So angle one and angle two would be considered alternate interior angles, and alternate interior angles are congruent. So on this one, angles one and two would be the exact same angle. Measure at least. So this is an angle of depression, this is an angle of elevation, but they're the same measurement, same number of degrees. Number three, he's looking straight out and then looking down, so that's an angle of depression. From person to, we'll call that's a house or a cabin, whatever you want to call it. And then angle four would be an angle of elevation from the house up to the person. Okay, so if you're looking down towards something, it's an angle of depression. If you're looking up, it's angle of elevation. Again, here, this angle 3 and 4, those would be congruent because they'd be alternate interior angles. So that's helpful to use at some point in a lot of these problems. So solve each of these application problems, and we're going to label our answers. So we're going to set it up like we did yesterday, and then we're going to solve it like we did yesterday. I should say set it up, and we're going to solve it like we did yesterday. So you see a rock climber on a cliff at a 32-degree angle of elevation. So it just means you're looking up towards them. The horizontal ground distance to the cliff is 1,000 feet. So here's you. You're a dot on the ground, and you're looking up towards a rock climber who's going up a cliff. That you're looking up 32 degrees. You are 1,000 feet from the base of the cliff, and they want to know, so find the line of sight distance to the rock climber. So line of sight distance, I'm just going to call that A because that's letter A, and then B is how high up the cliff is the climber, so I'm just going to call that B. Instead of X and Y, I'll just use A and B because that's what we're solving for, is A and B. So on this one, if I'm using angle 32, I know the adjacent side. So I want to use adjacent in both of these problems. One is adjacent over hypotenuse, so that's cosine. So cosine 32 equals adjacent over hypotenuse. I know how to solve that from yesterday, so I'll do that in a second. But then here, adjacent and opposite is how the combination I'll use to solve for B. That's tangent. So tangent 32 equals, remember it's opposite over adjacent, so opposite over adjacent. Okay, so if I want to solve this, I'll take 1,000 times tangent 32. Over here, got flip-flop these, so A is going to equal 1,000 divided by cosine 32. So put these in the calculator. This is 1,179. It says round the nearest tenth of a foot, so 0.2 feet. And then on this one, how high up the cliff? If I type that in the calculator, it's 624.9 feet. Okay. So the difference is you got to set that up yourself. You're setting up the equation and then solving it. Whereas yesterday we just gave you a picture and said solve for the side. You're flying at 17,500 feet in an airplane. You can see an airport in front of you at an angle of depression of 9 degrees. So you're up here in an airplane. You're looking, so here straight out, you're looking down at an airport over here. So this is a 9-degree angle right there. You are 17,500 feet in the air when this happens at this moment. How far does the plane need to travel on its path to safely land at the airport? So the way I read this, if I was doing this problem, is I'm going to travel on this path, I'm going to come down. Now, airplanes don't travel necessarily straight down like that, but we need to travel this way. What distance? So that's my x. Now, if you notice, the only angle I know in this triangle is that angle right now. That's a right angle. But I also know this is 9 degrees. Well, these are alternary angles, so this is also 9 degrees. If there was somebody at the airport looking up at the airplane, they would look up at 9 degrees at an angle of elevation because they're the same. So for those two, they're going to be the same thing. So if I need to solve this guy, that's opposite hypotenuse. Those are the two sides I'm dealing with here. So that's sine. Sine of 9 equals 500 over x. Again, when it's over x, you just flip-flop those. X is going to be 17,500 over sine 9. Put in the calculator. So it's going to be 111,867.9 feet. It's pretty exact, but pretty close to that. That's how far it's going to have to travel. Number 3, you're looking for buried treasure. While floating along on the ocean, your radar senses something on the sea floor at an angle of depression of 13 degrees. So you're up here floating on the water, which that happens to be, your horizontal line, and you recognize something at an angle of depression of 13 degrees over here. You know at the bottom of the ocean, straight down, is 700 meters. How far must the boat travel to be right above it? So we're going to go this way. So we're really trying to find this is like our x. Well, if you notice, that line and this line are going to be the same thing. So I can also call that x. And then if this is 13 degrees, this is 13 degrees. So it helps me set up my triangles here. So I got opposite and adjacent, so that's tangent. So, and then opposite over adjacent, 700 over x. So x is going to be 700 divided by tan 13. This will be 3,032.03 meters. So you could really just round it to probably 3,032. So depending on what Math Excel wants you to round it to. I'm standing on top of a skyscraper looking down at the city. I see the edge of the lake 5 miles away. So I'm up here on the top of a skyscraper. I'm looking down way over here. Here's the lake. The building is 700 feet tall. Notice that's feet, and this says 5 miles. So before I do anything, I want to convert that 5 miles into feet. If you take it times 5,280, remember 5,280 feet in a mile, this would be 26,400 feet. Okay, let's see. what is the angle of depression? So what is this angle right here? Well, that's going to also be this angle. So if I solve for one, I solve for the other. So this is the two sides that I know or want are opposite and adjacent, so that's tangent. So the tangent of whatever this angle is 700 over 26,400. Remember, when you're missing the angle like that, you're going to do inverse tangent. So I'm going to do inverse tangent of the ratio. This will equal x. Okay, so anytime you're solving for x, do the inverse. And that ends up, and if you think about this, this is, you're up pretty high. It's a pretty tall skyscraper, but it's 5 miles away. So this angle, you're not looking down very much because it's way far away. So this number should not be very big. In fact, it's 1.52 degrees. It's not looking down very much at all. A surveyor stands 200 feet from the base of a building. So here's our building over here. And then we're 200 feet away from the building to measure its height with a 5-foot surveying tool. So they're using this surveying tool is 5 feet off the ground. You ever seen one of those things that's like a tripod and they look through it? I'm not sure how it works, but it uses angles and all kinds of stuff like this. So it's very, very, very accurate. So it's 5 feet off the ground. So I'll put a 5 there, 5 feet off the ground. The angle of elevation from the top of the tool, so that is from here, is to the top of the building is 35 degrees. We want to know how tall is the building. Well, first off, I can find this value right here. I can find that x by making a right triangle and then add 5 to it. So I got 5 feet here. That when I do that, basically I'm doing that triangle right there, and I'm going to add 5 feet to it to get my final answer. So I want the opposite side. I know the adjacent side, so that's tangent. So opposite over adjacent. It's one of those where you can just multiply. So 200 tan 35, and so x, that ends up being 140.04. Again, we got to add the 5 feet because that did not account for the surveying tool. So it's 5 feet more than that. So it'd be 145.04 feet. Okay. So hardest part today, you got to kind of draw your own picture, or at least envision your own picture before you solve the same kind of problems you did yesterday. So if you did really good, really well with the problems yesterday, then hopefully today won't be too much more work.